Okay, let us now look at this question. Okay, it says that the diagrams below show a uniform rod with its midpoint at a pivot. So it's at the center, the pivot is at the center of the rod. Two equal force, which says that it's the same amount of force, are applied to the rod. Which diagram shows the rod, which is in this very important keyword called equilibrium? Equilibrium means that the beam should stay totally horizontal. So let us try to analyze each diagram slowly. You look at option A. In this case, there's a force on the right of the pivot which is acting up. So in this case, if it's acting up and it's rotating about the pivot, you will actually produce a anti-clockwise moment. Okay, so this is the due to the force acting on the right. What about the force acting on the left? Because it's acting down, so you also produce a corresponding anti-clockwise moment as well. Okay, because it's rotating about the same pivot. So if anti-clockwise moment and you add another anti-clockwise moment, it will actually create a resultant anti-clockwise moment. So it cannot be in equilibrium because the final rod will look like this. Okay, it will be moving towards the left side of the rod. Okay, so option A cannot be the answer because I want to see a rod that is totally horizontal. Okay, let us now look at option C. In this case, option C on the right F, it will produce a clockwise moment due to the about the pivot, and there is a corresponding anti-clockwise moment about the pivot. Because the force amount is the same and it's at the midpoint, so the permanent distance from the right action of force to the pivot on the left and on the right is the same. So in this case, I can safely say that the clockwise moment is equal to my anti-clockwise moment, which is a case of equilibrium, which the beam will just stay horizontally. Okay, so the answer in this case will be option C.